this lesson is about using the differentiation formula for transcendental functions. So at the end of this lesson, you should be able to apply properly the differentiation rule to determine the derivative of a transcendental function. Listed here are the differentiation rules for the transcendental functions. Please take note that in all of the differentiation rules, u is to be taken a function of x. A is a constant, e also is a constant. So for the logarithmic functions, we have two differentiation rules as shown. For the exponential functions, we also have two differentiation rules. For the trigonometric functions, we have one for each of the 6 trigonometric functions as follows. For the hyperbolic functions, we again have 6 as shown in this slide. For the inverse trigonometric functions, since we have 6 trigonometric functions, then we have also 6 inverse trigonometric functions, and the differentiation rules are as follows. And lastly, for the inverse hyperbolic functions, we also have 6 as given here. I strongly advise that you memorize all of these differentiation rules to be able to differentiate a given transcendental function properly. Now we illustrate how to make use of the differentiation rules for transcendental functions. And for our first example, we have f of x is equal to the natural log of the cube of 1 minus 2x. When you are given a transcendental function, it would be best to recognize first the nature of the function given you. In this case, what we have is just a natural log function. It is the natural log of 1 minus 2x cubed. So, fitting this to the form ln of u is the cube of 1 minus 2x. Also, when you're working with logarithmic functions, there are times that there is a need to transform the given expression to easily differentiate it. So in this case, we will be transforming the function f of x in some other form that is easier to differentiate. Okay, now in differentiating the function, let me just mention it, that since we have recognized that the function is of the form ln of u, then its derivative would just be given by 1 over u times du dx. Also, we can rewrite or transform the given function in another form using this property of the logarithm, where log of b to the n to the base a is equal to n times log of b to the base a. So, making use of that particular property, then log or the natural log of 1 minus 2x to the third power can be written equal to 3 times ln of 1 minus 2x. It is this formula that we now differentiate, and that the derivative would just be given by 3 times the derivative of ln of 1 minus 2x, where the derivative of ln 1 minus 2x is given by 1 over 1 minus 2x times the derivative of 1 minus 2x, which is just a negative 2. Simplifying f prime of x, we have it equal to negative 6 divided by 1 minus 2x. Now let us look at the case of y defined as 3 times sine of 4x cubed times cosine of 4x cubed. In differentiating this function, we will be applying the rule to differentiate a product, considering that what we have here is a product of sine of 4x cubed with cosine of 4x cubed. So applying the product rule for differentiation, the derivative of y with respect to x would be given by this expression. We have 3 times the quantity, sine of 4x cubed times the derivative of cosine 4x cubed plus cosine of 4x cubed times the derivative of sine 4x cubed. In differentiating cosine of 4x cubed and sine 4x cubed, we will be using the rule as shown. Okay, so we have the derivative of sine u with respect to x is cosine u times du dx, and the derivative of cosine u with respect to x is given by negative sine u times du dx. So applying this, then dy dx would just be given by 3 times the quantity, sine of 4x cubed times the derivative of cosine 4x cubed given by negative sine of 4x cubed times the derivative of 4x cubed, which is 12x squared, plus product of cosine 4x cubed with the derivative of sine 4x cubed as given by cosine of 4x cubed times 12x squared. Now please take note that among these terms, we have the common factor 12x squared. And whenever this is factored out from the sum, then the derivative dy dx is given by 36x squared, that is coming from 3 times 12x squared, then times sine 4x cubed times negative sine 4x cubed to give us negative sine squared 4x cubed. And then the second term will just be product of 4x cubed with another 4x cubed as accounted by sine or cosine squared of 4x cubed. Now, dealing with trigonometric functions or trigonometric expressions, we can simplify this applying trigonometric identities. And in this case, the particular trigonometric identity that will help us simplify the expression would be this identity of cosine to theta equal to cosine squared theta minus sine squared theta. Using this identity, the sum cosine squared of 4x cubed minus sine squared of 4x cubed is now replaced with cosine of 2 times 4x cubed. Hence, y prime or dy dx is now equal to 36x squared times cosine of 2 times 4x cubed, or that will give us 36x squared times cosine of 8x cubed. Number 3 function given us is just an inverse sine function, where y is defined the inverse sine of x cubed. So this particular function can be fitted into the inverse sine u form. And when you differentiate this given function, then we will be applying this rule for differentiation. Okay, where our u is x cubed. And as such, y prime will just be the derivative of inverse sine of x cubed, or that would be given by 1 divided by the square root of 1 minus the square of x cubed times the derivative of x cubed. Or we have 1 divided by the square root of 1 minus the square of x cubed times 3x squared, or y prime is equal to 3x squared divided by the square root of 1 minus x to the 6. Another example is defining f of x to be equal to the natural log of the hyperbolic sine of x squared. Again, as I mentioned earlier, it would be best for you to recognize first the nature of the function given. And in this case, what we have is a natural log function where the argument u is the hyperbolic sine of x squared. So this is again of the form ln of u. And to differentiate the function, we will be making use of the rule to differentiate ln u, and that will give us for derivative 1 over u, where u is the hyperbolic sine of x squared, times the derivative of the hyperbolic sine of x squared. And using this rule here, where u is x squared, then the derivative will just equal 1 over the hyperbolic sine of x squared times the hyperbolic cosine of x squared times 2x. Now, using this particular hyperbolic identity for hyperbolic cotangent of u, the ratio of hyperbolic cosine x squared to hyperbolic sine of x squared is now replaced with hyperbolic cotangent of x squared, and therefore we now have the derivative f prime of x equal to 2x times the hyperbolic cotangent of x squared. In summary, in order to differentiate transcendental functions properly, we must be able to identify first the nature of the transcendental function given us. It may be a trigonometric function or a logarithmic function or some other transcendental functions. Only on this basis can we determine which among the differentiation rules would apply. That will be all for today. I will see you in the next lesson.